So hello everyone. Today we will discuss load, stress and stress in the subject strength of material. Myself, Dr. Irshad Ahmad Khan, working as associate professor at Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. Let's discuss about this subject. Before going into the detail about load, stress and stress, let's understand what is the subject name, that is strength of material. So this strength of materials, also known as mechanics of material. In this particular subject, we are studying the behavior of solid object um, under the stress and strain, and these stress and strain are produced due to the external loading. And also we can define the strength of material, that subject which refer the various method for calculating the stress and strain in structural member or mechanical elements, such as a beam, column, and shaft, or any other machine component. The method employed to predict the response of a structure under the loading. So we have the various method to calculate the stress and strain. We will discuss in coming lectures. And let's understand load and its type. Load can be simply defined and set of external force acting on the any mechanism or engineering structure, um, and which they arise during the service condition in which the component works. So common type of the load, we can simply we are knowing the tension, and compression. So tension, when you can see this diagram, when the component applies some direct pull outside load, if you pull kind of load applied, so it is called the tension. If just reverse this direction, so it will give you compression load on the component. And simply we are using some sign convention. For tensile force, we give the sign positive, and for compressive negative sign. So a type of load, let's discuss type of load. So the dead load and static load, we can say. So non-fluctuating force and generally caused by the gravity. Suppose you are kept your water bottle on table, so your water bottle apply the dead load on the table, and live load, load due to the dynamic effect. And this you can understand the load exerted by the bus on the bridge, when the bus moving on the bridge. So what that is called live load, um, applied on that bridge. So impact load or shock load is just simple when the load is applied sudden, and it's like you throw um, a piece of stone on the ground. So that load exerted by that stone on the ground, at that moment of time, it is used the impact load. Fatigue or fluctuating load, and that is when the magnitude and sign of the force changing with the time. So it is called the fatigue load. Some cyclic kind of loading is applied, so it's come under this type. Definition of stress, let's understand simple, very simple, is that the force of resistance per unit area offered by the body against the deformation. The external force acting on the body is called the load or force, and the load is applied on the body while the stress is induced in the body. When the resistance offered by the material against the deformation and applied are equal to the loaded material, is said to be a being equilibrium condition. That simple, you can understand when your external force is applied here. So the material, if you consider this part, here some resistance is developed. Material is resisting against the deformation, and till material is not deformed, at that time this applied load and the resistance developed inside the material are in equilibrium condition. So when the um, let's understand by the mathematically. So you already, we know that the load per unit area. So simply load is P and cross sectional area is A. So we can say we can say P upon A load. So it will give you the amount of stress developed in this component. And if P is this or what is the stress, you can calculate that simply. You just divide by 1000 by 10, so it will be 100 Newton per meter square. The unit of stress is Newton per meter square, and Newton per meter square is also known as a Pascal. So you can say 100 Pascal. Let's understand about the strain. So strain, when the body is subjected to some external force, there is some change in dimension. Simply you can know when your external load is applied. So if the dimensions of the body is change, dimensions body of so dimensions of body change. So that ratio of change in dimension of the body, its original dimension, is known as strain. And because you know that both numerator and denominator have same unit, so it is a dimensionless quantity. Strain is dimensionless quantity. Tensile strain, compressive strain, volumetric and shear strain will be discussed in the coming lectures. And let's understand the ratio of increase in length to the original length of the body when subjected to the pull force. Okay, pull force we have seen like this. Compressive, the reverse of that. The ratio of decrease in length to the original length of the body when subjected to the force, and volumetric ratio of change in volume to the original volume of the body, and that is called the volumetric. It's give you the volumetric strain. And shear strain, and strain due to the strain due to the shear stress. So type of stress you can also see by this representation. You can see the stress, direct stress, are also known as simple, indirect, or combined. Combined means the both mix of direct and indirect, and that the shear stress, normal stress, and this indirect is torsion and bending stress. And normal stress can be defined as tensile stress and compressive stress. And this representation you can see when the applied load is applied in a direct push on the body. It's give you the compressive stress, and opposite of that, when the direct pull is there, so it's give the tensile stress. And if the direction of force or load is applied tangentially to the object or body, so it's give you the shear stress. And if it is a kind of twist in that body, load is kind of twist, so it give you the under torsional stress. It generate torsional stress. And if the load is applied like this, and there is two support is here, and it's give you the bending stress. Hope you understand the type of stress. And types of direct stress, normal stress when the you can simply understand stress in which act directly perpendicular to the area. Normal stress is further classified tensile stress and stress induced in a body when it is subjected to two equal and opposite pull tensile force. As the result, there is a tendency in the increasing length. That's simple. In the last slide, I made you understood. So, if the pull kind of load is acting on the body, and it's give you the tensile stress, and it's act normal to the area and pull on the pull on the area. So tensile stress you can see like this. This is an object. When you apply the direct pull to the body, and their resisting force in this cross section exists. So you can see resisting force R, and here till there is no deformation. So resistance force R and this applied force P's are equal. They are in equilibrium, you can say. So mathematically we can calculate about P upon A. Okay, so resisting force upon cross sectional area, and applied force upon cross sectional area, that it is written because of till there is no deformation, both resisting and applied are equal. That's why it's written in two times like that. Tensile tensile strength, increase in length upon original length. So we will get the tensile strength here in under when the load is applied um, directly pull kind. So compressive stress, the same thing you can see here. Then compressive load, or you can say direct push is applied here, and this kind of phenomena happen here, and which the stress produced in this scenario, and it will be a compressive kind. Shear stress. In the shear stress, you can say one body is bottom side, it is a fixed, and you apply a load at this end, this end, so it is little deformated. And in this case, what stress is generated, that is called shear stress. And shear stress here, the angle this phi, it is represent the shear strain, and this angle is very small, so we can write tan phi is equal to this dd1 upon AD, or or we can say this DL upon this height H. So hence the shear strain here DL, this DL, this deformation, this displacement upon the total height of this object. So we can write shear strain DL upon H. So thank you so much for listening this lecture. Hope we will meet again to more interesting lecture.